Hey, how's it going? Before we jump into the content, I just want to take a minute to thank you for stopping by the channel and checking out the content. If you like this content and you want to support more content like it, then make sure to subscribe to the channel and like this video. You can also check out the YouTube membership program and cybertrainingpro.com, where I put practice exams and other things that I couldn't put on YouTube. Again, regardless of how you support the channel and my content, I couldn't be more appreciative. Thank you so much, and let's get into the content. Believe it or not, networks haven't been around forever. Prior to the internet actually taking off, you had to sneakernet files from one computer to another, which means that you literally had to put files onto a disk and walk it over to that other computer. What a pain. Ethernet really allowed computers to network together and take advantage of that technology. Xerox, all the way back in 1973, developed a new technology called Ethernet, which allowed digital transfer of data at a whopping 3 megabits per second, or 3 million bits per second. That's crazy. This later evolved into the digital Intel-Xerox DIX standard, which then Xerox decided to partner up with Digital Equipment Corporation, DEC, and Intel in 1979. Eventually, this group transferred control of Ethernet to the Institute of Electrical and Electronics Engineers, or IEEE, so that they could develop the open standard that we know today as 802.3. I want you to take a good look at this chart that has the 802.3 standards, and you can see how it's evolved over time and the speeds that were when we first started till now. All network technologies deal with datagrams, packets, and frames, as we already talked about in the video on the OSI model. Frames address two networking issues. Frames prevent any single machine from taking over the shared bus cable because the systems listen and they make sure that nobody else is using the wire first. They make the process of retransmitting lost data more efficient. This happens because we can check for damaged or missing frames and just get those specific frames instead of the whole package again. For more specific details about how Layer 2 works and the contents of the frames, check out the videos on the OSI model for the Network Plus course. Early Ethernet networks were constructed as a bus network. This means that all computers on the network were connected on the same cable. As networks shifted to a hybrid star bus topology, the center device they used was called the hub, which is basically an electronic repeater that sent the signal out all of its ports. Now we're going to talk about the different types of networks that you'll see. In 1990, the IEEE 802.3 committee developed a version of Ethernet called 10-base-T, which allowed 10 megabits per second connection over unshielded twisted pair cabling. 10-base-T used pins 1 and 2 of the wires to send data and pins 3 and 6 to actually receive that data. This refers to how the wire is actually threaded into the RJ45 or the 8-position 8-contact connector. This is general information about how wires are threaded, so please don't go creating your own cabling in a business and just buy professionally manufactured cables to avoid any kind of issues. 10-base-T limits and specifications are listed on the screen, but speeds, we have 10 megabits per second, the signal type is baseband, distance up to 100 meters, and the node limit less than or equal to 1024 nodes per hub. The topology is star bus, physical star, logical bus, and the cable type is Cat3 or better UTP with RJ45 connectors. 10-base-FL is a fiber optic version of 10-base-T, and it's more for your knowledge. Some of the key specifications include speed of up to 10 megabits per second, the signal type is baseband, distance up to 2,000 meters. Topology is star bus, physical star, logical bus. Cable type is multi-mode fiber, 62.5/125 OM1 with ST or SC connectors. When you're dealing with bus networks, one of the issues is that all the devices are on the same network. If communications have a collision, then it's going to disrupt all communication because only one system can talk at a time. Carrier Sense Multiple Access with Collision Detection, or CSMA-CD, is a technology that detects if that line is being used, and then if it is, the system is going to back off slightly and wait for a little bit until it's available. CSMA-CD is disabled on modern full duplex networks, but you still need to know about it. So we know that hubs are basically a dumb device, meaning that they just repeat signals that are sent. We also know that when we're using hubs, that we can actually have collisions, and with CSMA-CD technologies, eventually the overall process leads to a less effective network because of all those systems that share a collision domain. For reference, if you hear about a bridge device in wired networking, these are older devices that act like a repeater to connect two networks together, and they could filter and forward traffic based on MAC addresses. Switches, sometimes called Layer 2 switches, are what we use today, and they're much smarter and can create point-to-point connections between two different systems. That eliminates all this collision nonsense from the old days. When you first power on a switch, it'll act like a hub by forwarding traffic out of all of its ports. As it learns where devices are connected, the switch is going to add MAC addresses to its media access control address table. Once the switch knows where a system's at, it can intelligently forward traffic between those systems based on MAC addresses to specific ports instead of blasting data out of all of its ports. On a switch, every port is its own collision domain, which means that collisions are a thing in the past. With that being said, a switch can send out a broadcast message to all of its ports except where it came from, making the switch have one broadcast domain. Make sure that you understand the difference between a collision domain and a broadcast domain. Sometimes one switch isn't enough, and we can chain switches together, either by using an uplink port or a crossover cable. Uplink ports allow you to connect two switches together using a straight-through cable, with one end in the uplink port and the other on any port. The port's literally going to be labeled uplink port, or with modern switches, you can actually configure any port to be this port using an auto-sensing feature called Auto Medium Dependent Interface Crossover, or MDI-X. Crossover cables are specially wired cables that reserve the sending and receiving pairs on one of the cable. One end will be wired according to the TIA EIA 568A standard, and the other is going to be wired to the TIA EIA 568B standard. Another note here is that when you're connecting devices that are the same type of devices, you'll need to use a crossover cable if it's not working automatically. One of the problems with connecting multiple switches is something called a switching loop or a bridge loop. That's because essentially the frames would keep circling around and never reach their destination. Luckily, the Spanning Tree Protocol, STP, was created to detect these potential loops before they occur using Bridge Protocol Data Units, or BPDUs, to work out all the paths. In STP, the root bridge is elected, and ports on other switches are intelligently set to this block state to eliminate redundant connections. These blocked ports still hear BPDU messages from that root bridge every 2 seconds, but if a link goes down, a topology change notification, a TCN, triggers, and some ports might change to a forwarding state instead of a block state. Switches usually have a setting called port fast to eliminate some of the redundancy caused by STP and the opening of a port, which also reduces some of the overhead on our switches. You'll only have this enabled on ports with PCs connected to them, not switches, and BPDUs should never come through these ports. BPDU guard is another technology that's useful, and it'll move a port configured with port fast into an error disable state, meaning that it's disabled if a BPDU comes in on that port. Then once that happens, an administrator has to actually manually enable that port. Root guard is another useful tool to help prevent another switch from taking over as the root bridge. You'll find these last three terms on Cisco switches, but let's face it, Cisco owns most of the networking world. Additionally, the Rapid Spanning Tree Protocol, RSTP, the 802.1W standard, replaced regular STP back in 2001, and it operates much faster. Switches are built to last for years and years, so problems don't happen on them very often. When they do, it's either because physical damage that you can easily see, dead ports, which are easy to spot when a port's dead because they typically have LED lights on them for the activity. You might also check the cable to see if it's a bad cable and it doesn't work. Like all things in technology, at one point the 10-base-T Ethernet standard seemed fast, but people wanted faster. Two standards emerged as the frontrunners. We had 100-base-T4, which used Cat3 cable, and we had 100-base-TX, which used Cat5 and Cat5e cable. Long story short, 100-base-T4 disappeared and 100-base-TX became the standard, although we just say 100-base-T today. You might even hear this called fast Ethernet. It includes speeds up to 100 megabits per second, the signal type is baseband, the distance is up to 100 meters between the hub or switch and the node limit of no more than 1024 nodes per hub and switch. The topology is a star bus, physical star, and logical bus. The cable type is Cat5 or better UTP or STP cables with RJ45 or 8P8C connectors. Upgrading from 10-base-T networks to 100-base-T networks is a huge pain. You have to install at least Cat5 cables. You have to make sure that your NIC card can actually handle that network technology. You also have to install a compatible switch. Luckily, this pain's largely been resolved by multi-speed, auto-sensing NICs and hubs and switches. That way the device could detect which speed it was dealing with and adapt. I've mentioned in other areas of this course that unshielded twisted pair cabling has a 100-meter distance limitation. This is problematic for larger buildings or campuses. Additionally, this kind of cabling can be disrupted if there's a lot of electromagnetic interference from nearby devices. One issue that I haven't mentioned is that UTP cabling can be tapped into fairly easily by simply slicing that wire, which doesn't help us keep our data secure. Luckily, 100-base FX provided a fiber optic option But keep in mind that even with this improvement, you aren't going to start installing this data technology today. Some of the key specs include speeds of up to 100 megabits per second, signal type of baseband, a distance of 2 kilometers between the hub and switch and the node, a node limit of 1024 nodes per hub or switch. Topology is a star bus, physical star logical bus. The cable type is multi-mode fiber optic cabling, OM1 with ST or SC connectors. 100 base SX was a short distance LED base alternative to 100 base FX, but this technology is dated today too. Now on the screen is a summary of both Ethernet and fast Ethernet technologies. I highly recommend that you commit all this information to memory. One of the issues with early 100 base T network interface cards was that they could only send and receive data, but they couldn't do it at the same time. We call this half duplex. Fortunately, over time, NIC cards have become more functional, and they include this auto negotiation feature for full duplex so that they can both send and receive data at the same time. Now, an easy way to think about this is a one-way road for half duplex, where full duplex has lanes going in both directions. It doesn't mean that data can travel at faster speeds, but it does double the network bandwidth. In the late 1990s, these 100 base options were just not enough for networks anymore. Enter gigabit Ethernet. IEEE standard for gigabit Ethernet is 802.3ab, called 1000 base T, but you also had another flavor under standard 802.3z, called 1000 base X. 1000 base T has similar features to other networks that we've already covered in that it uses UTP or STP cabling, and it has a 100 meter distance limitation. This version is also the most common today. Two other versions of gigabit Ethernet include 1000 base SX, which uses multi-mode fiber optic cabling with LED lights transmitting that signal, and they can reach cable lengths of 220 to 500 meters. Typically, the cable connector used is the LC version. We have 1000 base LX, which is the long distance carrier for gigabit Ethernet. It uses lasers to go up to 5 kilometers and potentially longer with repeaters. So what happens if you don't have compatible types of Ethernet? Luckily, a lot of manufacturers have created media converters that are either boxes or dongles on either side of the connection. Some types include single mode fiber to UTP or STP, multi-mode fiber to UTP STP, fiber to coaxial, and SMF or single mode fiber to multi-mode fiber. You might even see some devices called small form factor pluggables or SFPs that are hot swappable into devices like switches. 10 gigabit Ethernet connections are the next step past gigabit Ethernet. That's right, 10 gigabits per second. There are several different types, and the biggest things that you'll notice with this type are that the 10 gig base S are the only multi-mode types. The wavelengths vary. The W in the standard indicates SONET technology instead of LAN. The maximum signal lengths do vary somewhat drastically, and there's only one form of copper-based type, and that's the 10 gig base T. Manufacturers decided that instead of making a bunch of different standards, that they would agree to make the 10 gig connections work together. To do this, you can use a transceiver called an enhanced small form factor pluggable, or SFP+. Devices called bidirectional, BiD transfers are what we'll typically see here, and there's a specific wavelength that they deal with, like 1310, that you'll install on both ends of the network. It's not uncommon for organizations to have multiple speeds on their network. For example, a backbone connection might have high-speed fiber for servers or networking gear, and then the connections for users are slower. This can help control costs and minimize high-speed connections where it doesn't matter. Two final network speed options that we won't cover much are 40 gigabit Ethernet, which uses OM3 or better multi-mode fiber with laser light and enhanced quad small form factor pluggables, single mode fiber for up to 10 kilometers of distance, or it's even possible to run 40 gig Ethernet on Cat8 cable for a whopping 30 meters. And then 100 gigabit Ethernet, which uses multi-mode fiber and single mode fiber, again with quad small form factor pluggables, and has 4 channels of 25 gig each.